Welcome, Hornets, and thank you for joining me for part two of assignment number 6, found on page 254 to 354 to 355. We're going to be starting with numbers 27 and moving through 45, odds only, so please be aware of that. We're going to start with number 27, which is being asked to find the indefinite integral by use substitution. Now, as I've been telling people, you need to just go ahead and start the problem and don't be afraid of it. A lot of people get all frustrated because they say, "Oh, I don't know what to do." But just do the problem and don't let yourself get frustrated because you don't know what's happening. So here I have my integration where I have, my derivative, where I'm looking at this as 2x to the 1/2 power. 1/2 comes down in front, it becomes a minus, and then I multiply by the derivative of the inside. This is going to cancel a few pieces, so I'm now going to see that my du is equal to 1 over the square root of 2x dx. Now, don't let yourself get frustrated because somewhere in here we should be able to see a square root of 2x. It's right here. Notice I can now change this into the square root of 2x is equal to u minus 1, and now I can say that du is equal to 1 over u minus 1 dx, and therefore u minus 1 du is equal to dx. Now, this is just the manipulation that we're trying to work with, so don't let yourself get too frustrated. We can now take this and substitute our u in the denominator, and we have the u minus 1 du that's now in my numerator. Now, as I do this, I'm going to change it so that I have 1 minus 1 over u du. This is giving me u minus the natural log of u plus c. And now I'm going to go ahead and I'm going to put the various pieces back in. 1 plus the square root of 2x minus the natural log of 1 plus the square root of 2x. And then I have plus c. Now be aware, this constant here and this constant here can be added. So the actual answer, if you were to get this on an AP test, would hide that constant inside of C. And we would have this as the answer. So notice, although we can look at it this way, this is the correct answer that we would look for on a multiple choice question. That's why it's tricky and why you have to be careful. Let's go ahead and take a look at number 29, please. Number 29 is going to follow the same pattern. We have the square root of x in the numerator, and we have the square root of x minus 3 in the denominator, dx. We're going to start by letting u equal the square root of x minus 3. du is then going to be 1 over 2 root x dx, and I'm going to have to figure this out. So if I have 2 root x du equal to my dx, well, I'm going to first want to make sure that I have my u minus 3 is equal to the root x, because that'll get my denominator, but it'll also help me here so that I have a u minus 3 du equals the dx. Now I can start substituting various pieces. I'm going to have this 2 u minus 3. I have another u minus 3. Notice this right here is the du, and this is the root x. And then I have a u in the denominator. I'm going to have to simplify this now. So I have the 2 coming out. I have u squared minus, and let's just make sure that I have everything I should. Yes, I do. Minus 6u plus 9 all over u du. 2, I'm now going to have u minus 6 plus 9 over u du. That's going to give me 2, 1/2 u squared minus 6u plus 9 ln of u plus c. This is giving me the u squared minus 12u plus 18 ln of u plus c. And now I'm going to back substitute that u. So where was it? There it is. So I have the square root of x minus 3 squared minus 12 square root x minus 3 plus 18 ln square root x minus 3 plus c. Now I'm sure that I can probably simplify that 29 in number 29. I think I can simplify this by getting a positive 36 and adding that 36 in. And I see no reason why we shouldn't. So let's just go ahead and kind of clean this up. Square root of x minus 3. I am not going to FOIL it out. And I now have c, and that would be my final answer right here, and not that one. Okay, so once again, be aware that I went back through looking to see if I can distribute, get a constant to add into my c. Now, I could even FOIL this out if I really wanted to. After all, that would give me an x. All right, let's just go and do it. All right, minus 6 root x. I'm now looking at an additional 9, a 12 root x, plus 18 ln root x minus 3 plus c. And now I have x minus 18 root x plus 18 ln of the square root of x minus 3, and then I have plus c. Now you can even go so far as say that is my final answer, and there's not much more I can do to it. Gotta love it, huh? That was 29. Let's go ahead and take a look at the next group of problems. This was starting with number 31. These are now dealing with trigonometry. So we have cotangent of theta divided by 3 d theta. So what I'm going to do is let u equal theta divided by 3. du is 1/3 d theta. That's going to give me 3 du equals 1/3, is then going to equal d theta. And now when I do this, I have 3 cotan of the u du. And then we're just going to go ahead and we're going to integrate these following our patterns that we have. So we're looking at cotangent, and our cotangent is the natural log of sine. So 3 natural log of the sine. We're going to have to put our u back in. So this is theta divided by 3, and we have plus c. Okay, and that's what I've got. That's my answer. And they're going to continue with this with the basic substitutions. Let's move up to number 43, please. Number 43 is where we're looking at dy dx. And we're now solving our differential equations. And we're looking for a particular solution. They've given us a point. This is where we see our slope fields, and the slope fields are happening in numbers 49 and 50. Alrighty, and we'll be taking a look at those probably in another video. Let's go ahead and start by separating our variable dy, and I'm going to call this 3 1 over 2 minus x dx, dy equals 3, 1 over 2 negative dx. This gives me y. We have a negative 3 ln of 2 minus x plus c. This is where we're going to have to plug in the point. We know that our y equals 0, negative 3 natural log of 2 minus 1 plus c. 0 has to equal c, and I now have y equals negative 3 natural log of 2 minus x. Now this can be simplified. After all, using our properties of logarithms, this can bring it down, and I can end up with the natural log of 2 minus x, and then this is cubed. Okay? So one of these two answers would be my answer. Let's take a look at 45. This is the last one from this section, then we move on. And we're looking at finding our particular solution. Whoops, let's start again. We don't jump ahead. You jump ahead, you're going to lose points. So we have dy dx equals 2x over x squared minus 9x. Now I say lose points because I like to see all of the work, showing all of your work and breaking it down slowly, in my opinion, is a much better way of doing things than rushing through a problem. So take the extra step, set up your problem cleanly, get yourself ready for the u substitution. You know you're going to have it. The question then becomes, wait a minute, am I going to have it right? And I look at this and I say, wait a minute, no, I got a problem here. My u substitution is going to have a 2x, but I have a minus 9 dx. So I'm going to change this so that I have a 2x minus 9 plus 9, and I'm going to set it up as two distinctly different integrations. Notice how we do that in a very kind of clever way. Okay? Alrighty, let's see how this is going to go. So right here, I'm looking at my u sub. That was the whole idea. We now have u equals, du equals our dx. So our u originally was x squared minus 9x. So I now have 1 over u du, and I just have to deal with this piece right here. Now this, I'm going to have to get clever, and I'm going to have to look at this as trying to get some kind of a power down there. Now, normally I would just try to complete the square by adding and subtracting and go with my trigonometric arc tangent or one of those other ones. I suspect that they're just going to try and ask us to do something similar. I see I have an error. I wrote the problem down incorrectly. This just has a 9, and now my job is easier. I feel kind of stupid. Always check your work, please. At least this is what I'm supposed to see. So, doing this problem, let's go ahead and just stop this video after this problem since I do have that. I have dx. We're using our u substitution here. We have 2x dx. And according to the problem, x squared minus 9. If u equals x squared minus 9, du is equal to 2x dx. And I can now just do my straightforward y equals the integration du over u, which is y equals the natural log of x squared minus 9 plus c, we're now plugging 4 equals the natural log of 9 plus c, and there is a serious problem in this that I do not like. Let's see, that should be 16, first of all, 16, no, that's the 0, and I'm getting 4 minus the natural log of 9 is equal to c. All right, I'm going to go with it, and we're going to end this video. This is what I'm getting for my constant. And thank you very much. I hope you enjoyed this. If it's helped in any way, please click like. I'm going to go to part 3 next and continue with assignment 3. Thank you very much, and please be well.